Okay, so I'm going to go over the essay questions that you had to do on your final exam, particularly for people who were not here the day we went over them. So hopefully this will help you with answering essay type questions. So the first question that you had was this one. You have a graph, and they tell you that, I don't have all the information here, but on the paper it told you that you had two solutions and you had red blood cells. And so let's say this is solution A, this is solution B, and in each one of these were a red blood cell sample. And so we see the percent change in mass. We see that solution A, the red blood cell gained weight. So we know that what happened in solution A is that water went in. And then in solution B, we see that the cell lost weight. So water went out. Then they tell you that the actual solutions were 5 molar glucose in one and 0.5 molar glucose in the other. And they want to know which solution was which. Well, if we know that the cell falls somewhere in between the two, and we also know that water is always going to go towards the hypertonic side. Of these two solutions, 5 molar would definitely be more hypertonic than 0.5. So it would make sense that solution B has to be the 5 molar. That would cause the cell to lose weight, and if solution A was the 0.5, the cell must fall somewhere in between the two, and so this cell would gain weight. So you got a point for telling me which was which. 0.5 would have been A, and 5 would have been B. And then your second point would be for explaining how you figured it out. You couldn't just say that A was the 0.5 because the cell gained weight, because some people actually put that A was the 5 because the cell gained weight. So that in itself doesn't tell me that you really understood what was happening. What you did need to use were words like solute. There was, for example, more solute in the cell in the 0.5 solution, and therefore water moved into it. Or you could have also used words like this cell was hypertonic to the solution, or the solution was hypotonic to the cell. So on the AP exam, try to make sure you define things. Use words if you can, but if you can't remember hypertonic and hypotonic, if you just explained on the basis of the solute, you would still be able to get the point without actually using that vocabulary word. The second question asks you to predict how the graph of the cells in solution A would differ if it had been plant cells. So what they're expecting that you figure here is that this cell gained weight and then there's no more data after this. And so probably what happened is the cell burst or lysed. In a plant cell, we know that a cell will not burst because of the cell wall. So the explanation should have included something along the lines of the cell wall, and therefore the cell would swell and increase the pressure, but it would not actually burst. It would actually be able to reach sort of an equilibrium because the pressure would compensate. You could have also mentioned, and I don't know that you could have just mentioned this, that they have the central vacuole to store water. That in itself would not really explain why the cell didn't burst, but it could be something that you could add that would sort of go along with it. All right, the next section had a set of data, and let's just pretend like I had told you that this was glucose that the cells were being put in, or the potatoes were being put in. So the first question asks you to calculate the actual percent change in mass right here for this piece of data that's missing. So percent change is final minus initial over initial times 100. So the percent change in mass would have been 3.5 minus 4.2 over 4.2 times 100. It was really important that you remembered that this ends up being a negative number. That's a completely different answer than if you put this as a positive number. So be careful about that. So the correct answer comes out to be negative 16.7%, or if you round it to negative 17%. Remember on the AP exam, they're usually going to tell us to the nearest tenths place, tell us to the nearest whole number. So you'll know exactly where they want you to round. All right, the second one says that the temperature was 25 degrees Celsius, and they want to know what the solute potential was. And remember, you'll have your formula sheet. So solute potential is negative ICRT. Well, I, if the solution is glucose, is going to be 1. C is the only tricky part of this whole thing. R is the 0.0821. I don't have it in front of me. And T is going to be your temperature in Kelvin, which in this case is going to be 298. So the only thing that's missing is C. You were supposed to figure out C based on the data. Remember, C represents what would have been an isotonic solution. So if we know that in the 0.4 molar, the cell lost weight, and in the 0.2 molar, the cell gained weight, any acceptable answer would have been 0.25, 0.3, 0.35, anything that would be logical. So it seems to me that, I mean, a simple one would be 0.3, although it does seem like it may be a little closer to 0.2 than 0.4 based on the data. It really doesn't matter. I used 0.3, I think this actually is a 3 here, and I got negative 7.4 bars. Remember to put units. Use the formula sheet to figure out what units to put. And then the last question asked, using the formula for water potential, explain how a potato could be placed in distilled water and not gain weight. Well, distilled water would have a solute potential of 0. And so the question is, you know, based on solute alone, obviously water would go in. I mean, here's distilled water here, and obviously water went in. But if we know that our final formula for water potential is equal to solute potential, which was negative 7.4, plus pressure. Well, if our pressure was high enough, we could basically counteract the fact that the solute potential was negative. And so that was your answer, something incorporated. Some people just said if there was a higher pressure inside the potatoes. Some people said if the pressure was positive 7.4 or greater, any of that, but you needed to explain it based on the formula. So when they say something like that, remember to refer to the formula for water potential. So that was question 1. This was question 2. This was the most commonly answered question. Most people were able to answer it. The biggest problem with this one was part E. Almost nobody could answer part E. So this is actually from a practice exam from the College Board. I used the same information, I just changed the questions or asked different questions about it. Originally, the College Board one actually says that the original ones were purebred, black and cinnabar, crossed with red, gray and red. Mine actually had the opposite. Mine had black with red and gray with cinnabar. It doesn't really matter, but let's just go with the College Board one. So if the original ones were purebreds, which it told you in the question, I don't have the whole question here. Purebred for black would be big B, and cinnabar would be little r, and then gray would be little b, and then big R. Again, mine I had the opposite, so big B, big R, little b, little r. I gave a point for getting that cross correct. The second one says that they took the F1 of this and crossed them with a gray cinnabar. So I gave a point if you figured out what the F1 would look like, which would be big B, big R, crossed with little b, little r. So that was the cross, you got a point for that. Then they wanted the predicted outcome. And let me see if I can, wrong thing here. Let me just make a space here to show you that. So predicted outcome. So you would have done, you could have separated your B's and R's and done big B with little b, and big R with little r. And when you do that, you basically get half black, half gray, and then half red, half cinnabar. I gave credit for that. The actual prediction that they probably were looking for, though, would have been the chances of gray and red, black and red, in which case we can use the product rule, if you recall, and we basically would just say, so 1/2 times 1/2 would give us a 1/4 chance of black with red eyes, a 1/4 chance. You basically get a 1/4 chance of each one. So that was basically the answer to B. C, I worded very, very poorly, but all I was really asking you to do was to figure out, take your information here and figure out exactly what to do to fill in the table. So they told you that the total number of flies was 976, which you could have gotten anyway if you added this up. So there were 976 flies. Based on our data, we're expecting there to be basically 1/4 of each. So you want to just divide 976 by 4, so your predicted number of flies would have basically been 244 of each type. Based on the information we have, that's what you should have gotten in your crop. Then I asked you to do a chi-square and get your predictions. And people freaked out here because the chi-square fails so badly, they just assumed that they must have done something wrong. Normally when they fail, it's like you get 11.2 and you know the cutoff was 3 point something, but your actual chi-square here ends up being 653. You get 182, 145, 167, 159. So your chi-square actually comes out to be, give or take, around 653. I also asked in the question for you to give what the cutoff would be. Some people just totally forgot to do that, and that was an easy point. So your cutoff, we had 4 phenotypes, so 3 degrees of freedom. And if you go to the chart, remember the 5%, your cutoff would have been 7.82. So to get both points, you needed to tell me what your chi-square was, and that it fails, and that the cutoff was 7.82. And that brings us to the last section on this question, and I'm going to actually go to a blank page to go over that. So it says that a scientist discovered that the genes are linked. How would that explain the data? So if genes are not linked, then we assume independent assortment. In other words, we assume that if you have big B, little b, you have a chromosome carrying big B and a chromosome carrying little b, and then you have a second pair of chromosomes that on there is the gene for eyes, and so big R, little r. This would be big B, big R, little r. Now, if they're linked, that means they're on the same chromosome. So you would still have the same thing, but in this case, big B, now if you notice the data, and I don't have it in front of me right now, but if you notice the data, what ended up happening is almost everybody came out either black with cinnabar eyes or gray with red eyes. So if black and cinnabar eyes were on one chromosome and gray with red eyes were on the other chromosome, you would still be big B, big R, little r. But look what happens when we do independent assortment. This parent can give any combination of these chromosomes. So they could give big B with big R, big B with little b with big R, little b with little r. When you cross this with our little b, little r, we basically would get our prediction, which was 1/4 black with red eyes, 1/4 black with cinnabar eyes, 1/4 gray with red eyes, and 1/4 gray with cinnabar eyes. But if these were on the same chromosome, when this undergoes independent, or it doesn't undergo independent assortment, when this undergoes meiosis, you can only get big B with little r, because they go together as a package, and little b with big R, because they go together as a package. If you do the cross this time with little b, little r, all the offspring either come out black with cinnabar eyes, or gray with red eyes. Little b, or big R, little r, there. All right? And our data supports that. Now you might say, well, if you look at the data, there were actually 42 and 47 that had the other combination. The gray with the cinnabar and the black with the red. And according to what I'm telling you, that shouldn't happen. Everybody should have either been one or the other. But you have to take into account crossing over. The data really supports the exact thing you would get if 2 genes are linked and there was a little bit of crossing over happening. In other words, these are stuck together, so most of your offspring are going to come out like this. But if a crossover happens, remember prophase 1 of meiosis 1, we might have these switch places so that you now have some of the sperm or eggs carrying big B with big R now stuck together and little b with little r now stuck together. Now crossing over happens all the time, and as a matter of fact, the further apart they are, the higher the chances. If big B and little r are right here, then the chances of big B crossing over without little r is going to be much less. They're probably going to cross over together, so you're not going to see the combination. But the bottom line is, in answering the question, obviously this is not a paragraph type answer. It would help, but you'd have to write something other than that they're inherited together as a package deal, that would support the data, they're carried on the same chromosome, And if crossing over happened, that would account for the small amount